let's go to our project, because I promised you that on today's stream, we'll just go through the stuff I have here. I often show stuff in the same project, but some of you are confused what it is, where to get it from. So you go to techardate.com, you go to products, and here is asset files from YouTube tutorials. Click it. This is one way. You just get that, so you will find at least two things. Techardate UE5, Techardate UE4, and another thing from Twitch project is Twitch Prods Level Tools. So this Prods Level Tools is just a name because I thought I'd be creating a stream about procedural level creation. It ended up serving as my main project. So, but this is it. Unreal Engine asset files from YouTube tutorials. There's also one more method to get them. You go to patreon.com/techardate. This one gets you also the Twitch project files, but also the middle one is already with Twitch project files. And here you have Google Drive. In this Google Drive, you have exactly the same thing as you have here. This is the project, this Prods Level Tools. And inside, we have a lot of things, but we also have a folder called Maps. And this is what's most interesting. For example, open the Burning Wood map, and guess what? It's from this, fire damage to materials. Press play. Here we go. Go to maps and click through maps. Like, all of them are fun to watch, so why not do it, right? Audio visualization. Let's try this one. So this is a synesthesia plugin for Unreal. This is a synesthesia plugin. What does it do? It spawns cubes procedurally in Blueprint, probably. Oh yeah. As you can see, it's a graphical instance static mesh. Let me open Ctrl-E that blueprint. For the number of samples that we have from the anesthesia plugin, it creates a next instance like this. And then when we play, the instances represent the intensity, the amplitude of the sound at the given moment. But as you can see, there is a history. These 6 rows are slightly offset in time. So on the top you got the newest, and then they move further. Sorry, on the bottom you got the newest. Here I use it as a color. Here I use it as a height. And the color is passed to the instances in a specific way. Because as you can see, they are black, right? But this is a hierarchical instance static mesh, so we got only one material. So how is that possible? Here's this material. And what does it do? What does it do? Per instance, custom data 0 is taken from vertex to pixel. But this node, this single node, has a different meaning if you use instancing. If you use hierarchical instance static mesh, this little node means from instance to pixel, not from vertex. So it means that this value is per entire instance. The same if you picked position here, it will give you position of the instance. So this, and this per instance custom data set in Blueprint is used as emission intensity. So what does the Blueprint do? In the event graph, we get update audio viz, my own function. Let's go into it. It gets normalized channel constant QAT at a given time. Time in seconds. Here is the duration in seconds of the entire thing. I just kind of wrap it, loop it. I get the value. Here there is get instance count, so I know how many of these cubes I have. For each one, set custom data value. It's a function on hierarchical instance static mesh. You set the custom data index 0 and custom data value. which is the intensity. You press mark render stay dirty to refresh it. Normally you should do it only on the last instance, but I didn't care about optimization too much. And here on the calculate instance static mesh, there's one last important thing. Custom. Yeah, so in the instances tab, you have to go to advanced, number custom data floats. Set it, and then you can add custom data like this, either manually here or programmatically here. So this is important, not only the material, not only this, but also this num custom data floats. It's 0 by default. Let's go further. BP optimization map. It's basically a random movement blueprint that could be implemented either properly or in some bad manner. There's overlapping with the box, checking if it overlaps. A lot of things happening, and you can do it in so many different ways. So what was it for? There was a video, which is I think only for Patreons right now. So this video explains how I approach optimization in general. And then I move that knowledge to blueprints. So I talk about algorithm complexity a little, caching stuff, like calculating stuff once instead of recalculating every time, especially with pure functions, super important. And also I discuss different data types like floats, bytes, when to use. And I think I will return to this topic at some point because it's super important. People think blueprint is like the easy scripting, right? But even in easy scripting, you can do a lot of mistakes. It's better to use text or string, float or integer. Does that matter? Yes, it does. Okay, burning wood map. Simulate. Okay, so take a look. Things got hit by the box and they start to burn. How do they start to burn? What would happen if I moved them a little? They burn in the proper places when they are actually hit. But here are multiple spots, so do I paint a texture? No, no, no. I send 4 points, up to 4 points per piece, per mesh, using custom primitive data. So there's no texture, these are just 4 points. Up to 4 points. So let me play it again. It probably won't be visible, but if there's a 5th hit or a 6th hit, I'm recycling the oldest ones. So let me copy, maybe then we'll see something. Press play. Okay, and now if I move this, throw it away. If I move this, it actually overridden the first hits. Okay, so again, hits are here. Now I move it. Let me move the cube, it will be easier. Okay. Oh, I can't move the cube because it's physics. Physics. Enable physics. No. And now enable physics. Have you seen it? So it dropped the last points to reuse them again. So this is how it works. Which video is it from? Let's go to YouTube channel. And the video is here. Fire damage to materials. Pass hit points array from gameplay to materials. And in this video, I explain multiple concepts. So let me open the material here. It's quite a complex material. And it's the same material that you can find in the burning wood material video on the right. Okay. But then the points itself, where are they? Oh, here, look. I take the local position and through blueprint, I send fire origin and radius 0, 1, 2, 3. Fixed. points, a fixed number of points. I calculate a radial mask from each and then take a maximum, so I merge them together to form a single mask. And this mask I used in the material normally to show the fire. What is custom primitive data? It's a normal standard vector attribute or float, but on the left you enable use custom primitive data, and then this is what you have. This is black by default, but it can be set by blueprint without material instance. It's per mesh, and I use it in most of my tutorials recently. It's amazing because this is data that you can set per mesh, actually per mesh. You don't need separate materials. It's still one draw call. Multiple meshes, clones using the same material are just drawn together, yet they can have separate damage data, separate whatever. So this is great. We don't need the dynamic material instance, we just use this technique. Okay. Fire propagation map. Currently, I think it's trash because it doesn't do any fire propagation. There's an IRG assistant I want to use to read that scene and to propagate fire, but I failed. I didn't learn Niagara enough. But it was a fun experience to learn Niagara on the stream with you. Okay, galaxy map. Oh yeah, the galaxy, take a look. So this is basically volumetric rendering. Here we have a shader that draws a texture but with height in a transparent way. This is just a single plane, okay? Single plane. It works properly only in one direction. And it infinity draws Unreal logos outwards to the horizon. And these are not 16 planes, this is one plane with one shader. And here I think we have 16 actual, or more, 64 planes. So yeah, these are planes physically copied. And this is a single shader that simulates the same effect. Of course, it's heavier than a typical shader, but hey, at least we don't sort that stuff. We don't draw the overdraw. And then I used it to render a galaxy like this. It's not perfect, and it's still a single texture. It's not a volumetric texture. It should be, but it's not. But still, it's nice and soft, right? And these things are from a video here, volume materials 1 and volume materials 2. So how is it done? It's quite complex inside. This is a single layer, okay? And I calculate UV offset, UV parallax for every layer based on the view vector to that plane. It was quite hard to figure it out. It took us 2 streams to make it correct. So just copy this basically and watch the videos if you want. And then I'm adding some noise to break down the uniformity of that effect, to break down the stepping, the bending, how I called it. And then I sample this, the final result as many steps, 16 steps, or yeah, multiply by density, and that's it. Draw it to the screen. Multiple layers with UVs shifted based on the view to the surface. Such an effect, basically parallax. So this is it. A galaxy. This wasn't too pretty. I'm not satisfied at all. But this, I think, is quite nice. And I added some little stars. I don't know if you can see it, but there are some little stars. Geometry script map. What is it? So geometry script is a plugin. Go to plugins, geometry script, and it's just amazing. It's fantastic. It allows you to do much more than typical construction script. It's actual plugin for building geo, which ends up as a single mesh where you can weld the vertices. So there are no duplicates, there are no holes. All of this is a consistent mesh that doesn't bleed lighting and so on. And also you can unwrap UVs in Unreal in Blueprint. So geometry script is just perfect. It's not ideal, it's not perfect, but it's great. So here I try to recreate this building, but this time in geometry script. Of course, I know this would end up as a single module, so it's just an experiment, right? It's not the ideal way in this case. But what I wanted to do is to randomly remove some parts like this and randomly move the clothes on every floor. But I couldn't do this because in Unreal 5.0, which is already quite old, unfortunately, compared to the GitHub build, they don't have selection yet. They added it only later. So that's it. And the video itself, I think, is on Patreon. Introduction to geometry script. Glitches. Another map. So in this map, in the glitches map, I think I didn't upload the stream, but here I showed various problems related to Z fighting, related to too thin geometry, like this. One of these uses actual alpha transparency to kinda add some form of anti-aliasing. So as you can see, thin geo, very problematic thing. From up close, it's okay. Move far away, it just vanishes. The problem with streams about glitches is that usually Unreal handles a lot of stuff very well. Depth buffer is detailed enough to not have Z fighting visible, and so on and so on. So yeah, this was more about a talk rather than very concrete examples. But still, a lot of people in the chat said that they learned something, so it's good. Okay, global weather map. I really like that. Take a look. You press play. And the rain begins. The surface becomes unevenly wet. Albedo darkens. And only from the top. So when stuff is occluded, it's still dry. It's still dry. Inside, it's totally dry. There is no reflection like here. Okay. Instancing materials. This is about how to randomize materials, switch basically between multiple materials without adding additional draw calls. So this is explained in a Patreon post. This one, material tricks for instancing. However, there is a better video. It's on the very top. It's the newest one right now. Blending materials a high performance way. This is almost the same, but I moved the logic from using texture arrays, which apparently have too many pitfalls to use in production, and I recommend to watch to learn why, to using UDIMs. UDIMs are virtual textures with a very specific layout. And I recommend this if you ever want to blend materials in the, say, production ready way. So this is instancing maps v2. This map is about these UDIMs. So here we are, randomly mixing materials per instance. And again, one actor, one instance mesh, one material. There's nothing more. There's one material, one instance static mesh. Nothing set per mesh, not even custom primitive data. So how is it done? It picks one random texture from the UDIM. It picks another random texture from the UDIM. Applies styling, applies wrapping, yeah. Samples it from the virtual texture, which looks like this. Okay. And it performs this. So I really recommend to watch this if you ever are interested in layers materials or blending between materials or transitioning from one material to another, because you can also do it in real time. This is not a offline technique, it's real time. And UDIMs, the special virtual textures when you can have atlases of stuff, are very cool. Here you have atlases of all normals, all colors. Out of this, one material, one draw call, and very efficient blending, sampling just 2 variants, not every one of them. Light controller map. This was a request from one of the viewers. Take a look. We go to the light controller folder, right click on light controller and run. Here it pops up. This is a widget that we built out of a request. You can take the directional light and set to 50%, and again, and again. So it finds lights in your scene, it builds a list, and allows you to control each one of them. It's all dynamic. If I change the name of the lights and so on, change the number of the lights in the scene, it will change itself. So a light controller blueprint, like literally. You can open it, you can check how it's made, how it's done. Another map, Nanite tips. This map is not useful too much in itself, but it shows a lot of potential problems with Nanite. Here is a Nanite map where I tested a lot of stuff. For example, how do shadows, virtual shadows, handle Nanite? When I move in, is the detail realistic? Apparently, yes. It's very tracing Nanite very well. Then stuff like animated materials on Nanite, animated UVs, handled brilliantly, no problem. Then checking how it will optimize a little hard surface like this. Again, looks fine. And here, this is the wrong material, so let me change it. Material should be Nanite vert color. Take a look. This is vertex color, stored as Nanite triangles. It's actual vertex color. And see what it does to Nanite. Nanite already optimizes the rest of the mesh. Despite the mesh being dense, Nanite knows that it's completely flat, so we can optimize it. Here, it preserves it. Very cool. But then we move away and look what happened. I don't know if you can see it, but let me zoom in. What has actually happened? I'll fly closer. And here is the result of none. Okay. So as you can see, vertex color is rejected much quicker than position precision. So converting albedo and storing it in vertex color isn't a good idea. Look how quickly does it degrade. Quite quickly, right? So it's not a good idea. So people thinking that Nanite is also storing textures, no, it's not. It's best suited for position and normals. Rest of the data has to be simplified more because you will never reach degradation otherwise. It will always be high resolution. So it has to degrade like this, but actually it's stronger than expected. Oh. Another map. Pentile screen. I like that so much. It was my startup. By default, it shows nothing. But there's a scene capture to the actor. It draws stuff into a render target. So let's press play. The mesh is rotating and it's drawn there. To get proper anti-aliasing, I don't draw the Pentile screen pattern in the shader. No, I draw it off the screen onto a plane. And only this plane, this canvas, is drawn here as a material. So I'm pretty satisfied with that effect, how nicely it holds. So here I use Blueprint to actually draw stuff. I create a material instance where I can set all the parameters like brightness, the render target path, the image to be displayed. Then I create a copy of the render target and I draw texture. Not draw texture, draw material. I draw material. And material is the shader of this Pentile screen. This one. And Pentile screen. As you can see, this is what it does. I got a special function, squares on grid filtered. Probably inspired by Inigo Quidez, but maybe not. Yeah, right. On his filterable procedurals. And then I multiplied each color by a different weight, with green being the darkest. And here we go. This is up close, and this is zoomed out. So really, I'm really surprised by how well the color holds up. It's the same shader. There's no magic like by distance or something. So yeah, Pentile screen. Now physics scatter map. Take a look. Stuff is falling, okay. I press escape, it's disappeared. So go to the folder called physics scatter, right click on this, run, and this is my own widget. I press play. I select some of them and click Save Transform of Select. Here they are. I stop it, and now I press, in the stopped editor, I press Recreate Saved Meshes. Here they go. Exactly like simulated with physics. Here they are. Okay, so such a nice tool. And this tool is described in the video called Say Spawn Actors. It's only on Patreon, so here we go. Pretty shader 0, 0. Yeah, I did 2 streams. First was about Ferrofluid and iridescent material. That depends on the angle that you look at the object. Here's the ferrofluid. And this ferrofluid has a magnetic origin. Take a look. I take the origin away. The effect vanishes. Now I take this closer. Starts to do something. As you can see, it reacts to the origin. Like so. So I really like this effect, and I'm not sure why, but this is one of the least liked streams on YouTube. Like, there's quite a plenty of dislikes of this video. I'm not sure why. If you have a clue, let me know that I did do something wrong. And this was the second part that I didn't record, about doing an aurora effect in the shader. So all these are present here in the map. The recording is only about these two, and it can be found somewhere here. Ferrofluid, iridescence. Okay, render targets damage. Does it work? Random points are picked and damage is applied in real time. And I'm really sad that this recording is lost because I like this effect. I really do. We end up with a damaged mesh with cutouts. It's not a damaged mesh, it's damaged alpha, but still. I really liked this. Here, there's one of the problems with mixing I didn't solve. But anyway, cool stuff, I think. So this is render targets damage. Now, render targets snow. So here's a spline. It deforms the snow more and more, and it's a parallax effect. It's not displacing the geometry. It's just in the shader. So the setup is quite complex, and I explain it in the video Render Targets 2 Snow Deformation. Now, Fog of War. It was supposed to serve as a fog of war, but ended up differently. I did a signed distance field rendering of that map, and then I do my own algorithm for shadows. It's hard to explain, really. It's pretty hard to explain. So I just recommend to watch this video. Not signed distance fields, but a good introduction, but also do the shadows using signed distance fields. Here. ShaderToy map. Here I almost ported one of my shaders from ShaderToy and the second that creates a normal map. But it's surprisingly unfinished. Basically, I don't show any technique or any tool, any clever automated converter. No, I just show the reasoning and the way to port HLSL or GLSL code to Unreal, to nodes. So this is this video, porting ShaderToy code to Unreal Engine. Okay. Shaping functions. This is simple, but fun. Basically, I show how to make your own graph visualizer that visualizes a given function, mathematical function. Shaping functions. The scene itself doesn't matter, but in the video I show a ton of useful functions that you can port. Starting soon, map. You recognize that if you watch the streams. So my intro that you see before the stream starts is actually built in Unreal. This is what you're typically seeing before the stream starts on Twitch. It's all Unreal. It's a nice little shader that does this reflection. And it's pretty straightforward. There are not so many tricks. I'm just using planar reflection. I'm using a typical mesh. Mesh plane, but the reflection is not shader trick. It comes from Unreal and some Fresnel multiplications. Streetlights map. This one is cool. There's a bunch of lights. Okay. And if you press play, they start. First they randomize the color. That's what they do. Then they start to fall apart one by one. Random lights get turned off and simulated. One by one, they die off. Like this. So I show how to create a blueprint setup that communicates with that many actors efficiently and changes the light and the material together. So when I press play, so you can see warm lamp, warm light, cold light, cold emission. Stylized paper map. I very much like that video. Stylized post processes. It shows how to create various effects like oil, paint, how to create fish eye, and how to blur in post-process. I also explain a lot of potential pitfalls, the limitations. So yeah, this is stylized paper map, and you don't look at the assets, you look at the post-process volume here and search for the material. Post-process materials here. Here's the material. Oh. Post-process oil paint. Fish eye. Chromatic aberration. Virtual texture bake. I didn't finish it and I didn't publish that. This was an attempt to bake materials in real time into virtual textures, but it failed for multiple reasons. Yeah, but as you can see, I ended up doing exactly the same thing, but with a render target. So a scene capture actor, a mesh is unwrapped using a shader into a flat version, but with proper normals and stuff. And then it's rendered, and you can see it here. You can see it here. This is the result of the baked stuff. So yeah, I think this was quite interesting. But I didn't upload the video. It was, in my opinion, too chaotic. And Virtual Textures map is another stream I didn't upload because it was just me learning virtual textures, but it was very informative, I think, for everyone involved because we were just discovering stuff. Most of the people didn't have experience with them yet. Yeah, so the Virtual Textures map contains blending with the landscape. Take a look. Take a look. Blending nicely using, not so nicely, they're artifacts. Using Runtime Virtual Textures. So as you can see in that little project, there's plenty of stuff already. And of course it will continue to grow. So when you buy the package on Gumroad, remember to periodically visit the site and download again. Even if I don't update the changelog, because I don't do it usually. I upload every 2 streams, usually. So periodically visit this again and just re-download. So new stuff will be here. So that's it. If you don't have any questions, then have a great rest of the Sunday and see you next time. Cheers.